Hello 171 class, this is your notes for section 1.9, distance, midpoint formulas, and then eventually circles. Alright, so this is the distance formula. Distance between 2 points, these 2 points here. This distance d is equal to the square root of, if you subtract the distance between the two x coordinates, like the x coordinates are actually right here on the x-axis, okay? But if you subtract this distance between the x coordinates and square that, and then subtract the distance between the y coordinates, alright, and square that, there's the y coordinates on the y-axis, and then square those, add them together, then take the square root, you've got the distance between them. Okay, now if you look here, we've got a right triangle. Okay, this is a right triangle, and so this distance right here, x2 minus x1 squared, plus this distance right here, y2 minus y1 squared, equals, if you square both sides, it equals this squared, the distance squared, and it's literally the Pythagorean theorem. So the distance formula is basically based on the Pythagorean theorem when we're talking about rectangular coordinates. Alright, so let's practice it. Find the distance between these 2 points. We'll call this one x1, y1. It really doesn't matter which point you label x1, y1, and x2, y2. Alright, but when you go to the formula, the distance is equal to the square root of x2 minus x1, so that's 3 minus negative 1. Right, and then we square that, and then plus, now we do y2 minus y1, so negative 2 minus 4. And again, we square that. Alright, so 3 minus negative 1 is the same thing as 3 plus 1, so that's 4 squared, plus negative 2 minus 4 is negative 6 squared. Alright, 4 squared is 16. 6 squared is 36. Alright, and then 16 plus 36, if you add those together, you'll get 52. Alright, so the distance is square root of 52, but it tells us to simplify the radical. So if you recall, the way we simplify a radical is we pick perfect squares that could potentially divide that radical evenly. So they have to be a perfect square less than or all the way up to equal to this. If it's equal, then it's going to be it would be a perfect square under there. But we wouldn't pick like 64, okay, because obviously 64 is too big. But anything from 4 all the way up to 49 would be okay here to try to reduce this. So if I took 52 and divided by 4, it works. I get 13. Okay, because 13 is a prime number, that's going to be the number we use. But you would just try, divide by the different perfect squares, and if you got a decimal, then that didn't work, right? 52 divided by the next biggest perfect square is 16. That doesn't work. 52 divided by the next biggest is 25. Okay, that doesn't work. The next biggest is 36. Doesn't work. The next biggest is 49, which doesn't work. So it's got to be the 4. So we take the 52 and we write it as 4 times 13, and each one of those gets a radical. Okay, this is perfectly fine with math. Right? You can check with your calculator to make sure the square root of 52 is that decimal. Square root of 4 times the square root of 13. If you check that out on your calculator, you'll see that it also gives you that same decimal. So they are equal. And the reason this is called the simplified radical, the square root of 4 is 2 times the square root of 13. So the square root of 4 times the square root of 13 is 2 square root of 13. The radical, meaning the number underneath the square root symbol, is smaller. So that's a simpler form of a radical. That's what we mean by that. So when you see that simplified radical form, basically it means don't just leave it this way. Check to see if there's a perfect square that'll divide this number, and divide it by that number and get rid of any, get the smallest number you can here. Alright, and then the form rounded to 2 decimal places, that would be 7.21. And technically that's approximately, so we make those squiggly equals. Alright, but there's the exact answer. Okay, that's the simplified radical form, and then there's the rounded to 2 places. Alright, let's try it again. The distance is equal to x2 minus x1. Okay, so x2, x1. So 2 minus negative 1 plus y2 minus y1. So 3 minus negative 3 squared. Alright, so 2 minus negative 1 is 3 squared, plus 3 minus negative 3 is 3 plus 3, which is 6 squared. Alright, 3 squared is 9, plus 6 squared is 36 again, and then 36 and 9 is 45. Okay, 45 is not a perfect square, but there is a perfect square that divides it, and that's 9. Okay, so I'm going to rewrite 45 as the square root of 9 times the square root of 5, and then the square root of 9 is a perfect square, so that's 3 times the square root of 5. Okay, so there's the exact distance. The approximate distance is 6.71 to 2 decimal places. Alright, now let's look at the midpoint formula. Alright, so there's probably not a more intuitive formula in math. Like, meaning what you do to find a midpoint of 2 points is what you think you should do. Meaning, if I want to find the number in the middle of these, or the point in the middle of these 2 points, I take the average of the x-coordinates and the average of the y-coordinates, and that's the point. So I'm going to plot this point 1, negative 6 is right here, negative 8, negative 4 is here, and there is the line segment between them. Okay, now what we're doing here is we're trying to find the point in the middle. Let's color it blue. So roughly about right there. Okay, now that looks about where it would be. That would be negative 4, negative 5, but let's see if that's what we end up with when we do the math. So the x-coordinates added together divided by 2, that's 1 plus negative 8 divided by 2, comma, the y-coordinates added divided by 2, that's negative 6 plus negative 4. And then we divide that by 2. And this is going to be the equation, the coordinates of the new point. So 1 plus negative 8 is negative 7 halves, comma, negative 6 plus negative 4 is negative 10 halves, which is the same thing as negative 5. And then this, we could write it as, if you wanted, we could leave it the way it is, but negative 3.5 and then negative 5. So negative 1, 2, 3.5, negative 5, right there is our midpoint. Alright, and then you could plug in the distance formula if you wanted. You could plug this in, our new point with our original coordinate, and you would see with the distance formula that the distance is the same for both. And if you plugged in the distance formula from here to here, you would also see that the distance of either one of these is half of the distance of the total. Okay, but anyway, that's how you find the midpoint. You literally just average the x-coordinates and the y-coordinates. Alright, now a circle. A circle is just a point and a distance, basically. You know a point, that's the center. The distance is what we call the radius, and if you connected every single point from the center that's the same distance, that radius from that center point, you would create a circle if you connected all those points together. Now, if you see this, the distance between any point x, y on the circle and the center, which we're calling hk. If we plug that into the distance formula, right, the x coordinates would be x minus h squared. The difference between the y coordinates would be y minus k squared, and we add them together to the square root. That distance, d, we're just replacing it with r. So there's the distance formula. Okay, it's just we're applying it to this circle. Okay, now let's take this equation right here, the square root of x minus h squared plus y minus k squared equals r. We're going to square both sides of that. And when we square both sides of that equation, the left side, the radical will go away, and we're just left with the x minus h squared plus y minus k squared. The right side, though, we square r, so we get r squared. Well, that's it. There's the equation of a circle. That's where it comes from. The equation of the circle comes from the distance formula. And the weird thing about the equation of a circle is it is based on, like we just said, the distance formula is based on the Pythagorean theorem, which deals with right triangles. So that means the equation of the circle is also based on the Pythagorean theorem, right? If you think about the Pythagorean theorem, it said a squared plus b squared equals c squared. Well, this something squared plus this something squared equals r squared. That has the look of the Pythagorean theorem as well. So as strange as it may seem, circles are based on the equation of the circle is based on the Pythagorean theorem. Okay, now remember that r is fixed. It's a fixed radius. So what we're basically saying is if I drop down a line from any point on the circle down to the x-axis, right, and I intersect there at a right angle, there's your right triangle. And it's x squared plus y squared equals r squared if we're centered at the origin. Okay, x squared plus y squared equals, in this case, 2 squared, which is 4. Right, but at any point, if I pick some random point on the circle and I connect that point vertically to the x-axis, I get a right triangle. So basically a circle is every single right triangle that can be made with the hypotenuse equal to the radius. So that's why the circle, the equation of a circle, is based on the Pythagorean theorem, because it literally is every right triangle you can make with a fixed hypotenuse. Alright, but we're going to come up with things that look like this. It's just always simplify this. Don't leave it something squared, like 3 squared. You know, don't leave it that. We don't write 2 squared down here. We write 4. Okay, so make sure that if you know what r is, that you actually write it. Alright, so we got a center, negative 2, 3, and radius 4. Okay, now notice the center is hk. It's a minus h and a minus k. So when our center is negative 2, 3, what we do is we write the x minus the x coordinate, so minus negative 2 squared plus the y minus the y coordinate squared equals the radius squared. Okay, so initially that's what it looks like, but then we're going to go here and clean it up. Minus a negative is the same as a positive, so that's x plus 2 squared. And then always actually square that radius. So instead of 4 squared, we're going to write 16. Okay, so when you're giving me the answer, don't leave it like this. Actually square the 4 and give me 16. Alright, now let's plot it. We got 2 to the left and 3 up. There's our center. Alright, and our radius is 4. So the easiest thing to do here, if you're going to freehand this, is go out 1, 2, 3, 4. Go up 1, 2, 3, 4. Go left 1, 2, 3, 4. And go down 1, 2, 3, 4. So there's the points that you connect. You're connecting with an arc. Okay, so don't just draw a line. That's a diamond or a square. So don't do that. I've got a circle tool I'm going to use, but you know, if you're freehanding, just do the best you can. I mean, it's not going to be perfect when you're freehanding it. Alright, so there's our circle. So the thing that I want you to get down here is that the the thing I want you to get down with the circle is the sign change here. Right? When you got a x plus 2, that means the center is negative 2. You got a y minus 3, that means the center has positive 3 as its y coordinate. So change the signs in either direction. If you're given the formula and you're plotting it, or if you're given the center and the radius and you come up with the formula of the equation, you need to be able to understand that sign change that takes place between the point and what shows up in the equation. Alright, basically it's just 1.6 all over again. We're just shifting. It's just now that when we're in the parentheses, the y coordinate shifts in the opposite direction of the sign as well. So this is a minus 3, and we actually went up. Okay, but it would be x squared plus y squared, like that last example, if we're centered at the origin. But then when we shift the center away from the origin, it behaves just like the stuff in 1.6. We went left 2 and up. So the left 2 made us add 2 in the parentheses, and the up 3, because we're in the parentheses, we're subtracting that. Alright, find the center and radius of the circle who has this equation. Okay, so the center, opposite sign here, so that's a negative 3, comma, opposite sign here, so that's a positive 1. And then the radius is the square root of this constant. It's over here by itself, so it's the square root of 4, which is 2. Alright, and then graph the equation. So our center's negative 3, positive 1. So 1, 2, 3, positive 1. So there's our center. And then our radius is 2. So right 2, up 2, left 2, down 2. Alright, and then it says use the graph to identify the domain and the range. So domain, we're start from here, we're ending up here on the as far as the x's go. So that's negative 1, 2, 3, 4, 5. So negative 5 to negative 1, and they're both included. So brackets on both. And then the range, this is the lowest y, so that's negative 1. 1, 2, 3 is the upper y. So negative 1, comma 3. Alright, so there's the domain, there's the range. Remember, the domain is just the set of all the x coordinates on the graph. The range is the set of all the y coordinates on the graph. So all the x coordinates on this thing are between negative 5 and negative 1. All the range, all the y coordinates are between negative 1 and positive 3. Remember, it doesn't have to be a function to have a domain and range. Alright, and then the general form. The general form, we write it this way. X squared, y squared, xy constant equals 0. Okay. Now, we can go back and forth between general and standard. We just have to be able to do something called completing the square. So the way we do this is I'm going to regroup this. I'm going to put the 4x over here with the x squared. Then leave yourself a blank. Like write plus and then a blank. And then switch to the y's. So now plus y squared. And then this 6y I'm going to join with the y squared. So minus 6y. And then plus, leave yourself another blank, equals, and then I'm going to take this 23 over to the other side. So I would add 23 to both sides to get that 23 away from the left. So basically I'm adding 23 to both sides to get it to cancel on the left, and now it shows up on the right. Okay, so all I've done is just rewritten this with the x's together, the y's together, and then the 23 over on the other side. Okay, I've got these two blanks here. Now the reason I'm doing that is because I want to do something called completing the square. And to complete the square, if you remember this process, you're trying to make something that looks like x, in this case because this is positive, x plus some number squared, that when I expand this out, if I FOILed it out, I'd get these three terms, x squared plus 4x plus whatever this is. And same thing right here, I'm going to add, and then parentheses, it's going to be y, in this case minus something squared equals, and then whatever we get over here on the right. And what we're going to have to do, we're going to have to add something here, and then thereby we'll have to add the same thing over here to the right side to balance the equation. But the things that we add are the things needed for these three terms, this trinomial, to be a perfect square. Okay, and what it always ends up being is half of this number in the middle. So if we divide 4 by 2, we get 2. Okay, so that's the number that goes here. Okay, but the number that goes here, to get that, we have to square this number. 2 squared is 4. So that's the number we add here. That's also the number we add to the right side to balance the equation. Okay, remember these things are equal, so I can't just add 4 on the left and not add it to the right. Alright, here, same thing. I need to divide -6 by 2. That gives me a -3, so minus already, so I just need to put the 3 there. And then that's what I need to also square to know what to add here. So -3 squared is 9, so I have to add 9 to both sides. Okay, now, the only thing left to do here is add these three numbers together. 23 plus 4 is 27, plus 9 is 36. Okay, so there is this equation in the standard form. Okay, so you complete the square to get these two things in parentheses, and then you add whatever you need to add to complete the square to the right side as well, and that'll give you your square, your radius. Now if you FOIL this out, just to show you, if I FOIL out x plus 2 times x plus 2, which is what x plus 2 squared means, I get x times x is x squared. X times 2 is 2x, another 2 times x here is 4x, and then 2 times 2 is 4. And that is exactly what we have right in here. And then if you did the same thing with the y minus 3 times itself, you get y squared, -3y, another -3y, that's a -6y, and -3 times -3 is 9. Alright, so there's that piece right there. So that's what it means to complete the square. You add something here that is needed to make these three terms the perfect square, which is what we need for circles, right? We have to have that look for a circle in standard form. So anyway, I'm just showing you down there. That's what's that was the correct form there. All right, now let's plot it. So our center is -2, +3, and then the radius is equal to the square root of 36, which is 6. So -2, +3 would be right there, and then the radius is 6. So I'm going to go up to 9, go right to 4, left to -8, and then down to -3. So 9, 4, -8, -3. Okay, it doesn't look very circular, but that's because of the grids. Alright, so there's our circle. Alright, last example. This is a tough one. Okay, so what we're given here are 2 points. And we're told that these 2 points are on the circle and they form a diameter, meaning that they pass through the center. This line segment would pass through the center. So -5, +5, and 3, -1. Those 2 points, if you connect them with a line segment, form a diameter of a circle. Now if you remember, the radius is half the diameter. And also, the center of a circle is on the midpoint of the diameter, of any diameter. So what we need here is the midpoint formula. We need -5 plus 3 divided by 2, comma, 5 plus -1 divided by 2. Alright, so -5 plus 3 is -2 divided by 2 is -1. 5 plus -1 is 4 divided by 2 is 2. So -1, 2 is the center of the circle. Right, so that means we have x plus 1 squared plus y minus 2 squared equals our radius squared, whatever our radius is. We haven't figured that one out yet. Now, how can we figure out what the radius is? Well, we need to figure out the distance between the center and a point on the circle. So I just need the distance formula. Now I know 2 points. I'm just going to use the distance formula. And I can use either of those original 2 points. Okay, I could use both of the original 2 points, get the distance and divide it in half. But the easiest thing is to just use, since we know the center now, just use the center. Alright, x2 minus x1, I'm going to use this. 3 minus -1 squared. And then y2, -1 minus y1 would be -1 minus 2 squared. Okay, that's the square root of 3 minus -1 is 4 squared, plus 1 minus 2 is, -1 minus 2 is -3 squared. So that's 16 and 9, which is 25, and the square root of 25 is 5. So that means our radius is 5, and this says radius squared. So if I square 5, I get 25. So there's the equation of this circle. And then if I graphed it, I could have graphed it once I knew the center, but I needed to do all the rest of that to get the equation. So center out to a point on the circle. Alright, it looks like the no symbol, but that's what you have to do for this one. You know 2 points on the circle, and if those are endpoints of a diameter, the center is the midpoint, and then the distance formula will give you the radius.